In this, we will understand about queuing model MM1 colon FIFO/n/infinity. The first capital M denotes that the arrival rate follows a Poisson distribution. The second letter capital M denotes that the service rate also follows a Poisson distribution. The third letter 1 denotes that there is only one server or one service channel in the model. The next letter FIFO indicates that the queue discipline or the service discipline is on first in, first out basis. The next letter capital N denotes that there is a restriction for the number of customers to be allowed in the system. So it is a finite number which is denoted by capital N. The next letter infinity denotes that the size of the calling source population is considered to be infinite. Various parameters for this queuing model, we can find out the probability of having 0 customers in the system by using the formula 1 minus rho divided by 1 minus rho to the power of capital N plus 1 if rho is not equal to 1. And we will be using the formula 1 divided by capital N plus 1 to find out probability of 0 customers in the system if rho is equal to 1. The steady state probability of having n customers in the system can be found out as P suffix small n equal to rho power small n times 1 minus rho, the whole thing divided by 1 minus rho power capital N plus 1. This formula is applicable if rho is not equal to 1 and small n lies between 0 and capital N. We will use the formula 1 divided by capital N plus 1 for finding out P suffix n if rho is equal to 1. The average number of customers waiting in the system can be found out as L suffix S equal to rho times 1 minus of n plus 1 times capital N plus 1 times rho power capital N plus capital N times rho power n plus capital N plus 1, the whole thing divided by 1 minus rho times 1 minus rho power capital N plus 1. The average number of customers waiting in the queue can be found as L suffix Q equal to rho square times 1 minus capital N multiplied by rho power capital N minus 1 plus n minus 1 times rho power capital N. Denominator is same as the previous, that is 1 minus rho times 1 minus rho power capital N plus 1. The average waiting time of customers in the system can be found out as W suffix S equal to L suffix S divided by lambda times 1 minus capital P suffix capital N. Average waiting time of customers in the queue can be found out as W suffix Q equal to W suffix S minus 1 by mu. We will understand how do we apply all these parameters to solve a problem. The question is, cars arrive at a drive-in restaurant with a mean arrival rate of 24 cars per hour and the service rate of the cars is 20 cars per hour. The arrival rate and service rate follows Poisson distribution. The number of parking space for the cars is only 4. Find the standard results of this system. When we say standard results, we may have to find out this P0, LQ, LS, WQ, WS, everything. So given that the arrival rate and service rate follows Poisson distribution, hence the first 2 letters of the queuing model will have capital M in it. The question talks about a driving restaurant, which means that the number of servers is considered to be 1 only, which will become your 3rd letter of the queuing model. Nothing is specified about the service discipline, so the 4th letter in the queuing model will be considered to be FIFO only. Since there is a restriction for the parking space, the 5th letter will be capital N, and in this case, capital N is 4. Nothing is specified about the size of the calling source population, so the 6th letter in the queuing model will be considered as infinity. Therefore, the queuing model for this problem is related to MM1 colon FIFO n infinity. Now let us proceed solving the questions. Question has specified that the arrival rate is 24 cars per hour, so lambda value is 24. Service rate is specified in the question as 20 cars per hour, so mu value will be 20. Capital N, that is the restriction, is specified as 4, so capital N is 4. So our utilization factor is rho, which is lambda by mu, that is 24 by 20, which becomes 1.2. So we may notice that rho is not equal to 1. Hence, we will be using P naught formula as 1 minus rho divided by 1 minus rho to the power of n plus 1. Now, we will apply the values here. 1 minus 1.2 divided by 1 minus 1.2 to the power of capital N plus 1, that is 4 plus 1, it becomes 5. If we calculate this, we will get the result as 0.13. That will be your probability of 0 customers in the system. Next, we will calculate L suffix S. So if we apply the values, we get 1.2, that is rho value, times 1 minus of capital N plus 1, which is 5, rho power, that is 1.2 power 4, plus capital N, that is 4, times rho, that is 1.2, to the power of 5, because n plus 1. The whole thing divided by 1 minus 1.2 times 1 minus 1.2 to the power of 5. Close the brackets. If we evaluate this value, we will get 2.359 cars. Let us proceed to the next. LQ, that is rho square. So we can substitute 1.2 the square times 1 minus of capital N, which is 4, multiplied by 1.2 to the power of n minus 1. That means 4 minus 1. It becomes 3 plus n minus 1. So that is 3 multiplied by 1.2 to the power of 4 divided by 1 minus rho, which is 1 minus of 1.2 times 1 minus of rho, that is 1.2 to the power of 5. If we evaluate this after calculating, we will get the result as 1.494 cars. Rounding off, we may have to do that. We will do it. I mean, we can always do that anytime. Now, we need this P suffix capital N to be found. P suffix, we will be using this formula. So we will apply. Let us see what is P suffix small n. We will apply that first. That will be rho power n times 1 minus rho divided by 1 minus of rho power capital N plus 1. So if we substitute the values, we will have 0.3 times 1.2 to the power of n we will get. So that means our P suffix n will become now P suffix 4. That will be 0.13 times 1.2 to the power of 4. If we calculate this, we will get 0.2786. So now our WS value will become LS. LS we just calculated as 2.359 divided by lambda. Lambda is 24 as per the question, times 1 minus of 0.2786, because we already calculated P suffix capital N. If we evaluate this, we will get 0.136 hour. And if we convert that into minutes by multiplying it by 60, we will get 8.2 minutes. Then the next WQ, which is WS, so that will be 0. This will be 1363. So this one will be 1363 minus of 1 by 20. If we evaluate this, we will get 0.0863 hour. And that if we convert it into minutes by multiplying by 60, we will get 5.2 minutes. So that will be the solution for this particular problem.